have here is a short video on the relay that utilizes the Cat5 jack. I use these to switch on and off lights and some fans. I know there's probably other ways to do this wirelessly, but I like a good hardwired connection. Plus I have less wireless frequencies bouncing around all in my head and everything. For this it uses 5 volt to switch on the MOSFET that's mounted here, and 12 volt to power on the relay. And I didn't use a 5 volt relay just because, well, if you're running from a microcontroller, the output pins, well, they may be high enough to run a small relay like this, but if you're switching on and off several devices, you're better off just separating that out and having a different rail for your relay. So that way with these, if you're using say a prototyping board like an Uno or something, the pins for the Cat5 wire, they slide right in just fine. Now for the 12 volt, you'll have to figure out something different because you're not going to run 12 volt to this prototype board. So today I'm going to be expanding out my system so I can control a few more lights off my tablet from one central location, which is in here in this shop. I want to be able to control my lights in the storage room and out in the other part of the shop where motorcycles and things are stored. Now the pin out for the Cat5 wire is the 12 volt DC positive is the orange and white, 12 volt DC negative is the orange, 5 volt DC positive is brown and white, and the 5 volt DC is brown. DC negative is brown. Well, the reason I put a Cat5 jack on these is just convenience for me, really. Since I do use them, I have Cat5 and Cat6 is one thing I have a lot of, whether it's patch cables or just 100-foot pieces, or I don't throw any of it away. I keep anything that I use and cut off, so I always have Cat5 around. So that's why I decided to use these rather than a screw terminal and say like a 4 or a 2 pair wire conductor for like a security camera or something. If it's screw terminals, you could use something like that, but I think comparatively I do believe the Cat5 is cheaper and more accessible, and the voltage and current that you're running through with this is considerably less than what the rating is for the Cat5. I've been prototyping with this model here for a good while now. I'd say over a year. It works really well. I did have a first version that did have some problems. It had another integrated chip on there, and as well as a tactile switch, so you could also control on and off from here. But the board was a lot bigger. I didn't like it. It wouldn't fit in a junction box very well. It wouldn't fit behind, say, a switch, like a light switch. It wouldn't fit in the box. So I wanted to reduce it down and just eliminate that switch, and that's what I did. So I reduced it down to just this. I do recommend using some type of fuse system, especially for the 12 volt coming from the relay, just in case some kind of failure or anything happens, because there's really no protection on this circuit. And when I designed them for my own personal use, I didn't really need it. And I'll show you what I'm using and what I use to repurpose in order to make my little system here. And it all is still prototyped right now, and right now I'm using 3 different boards on it, and there's a reason for that. And it's because one controls the timer and one controls the thermostat, and I was having issues with the timer and the thermostat running off the same processor. So until I figure that out, maybe if I even can get them running off the right one. There was a timing issue. It was creating delays on the air conditioner, and something with the timer was, I think, creating false readings as well. So since I've separated them out and put my code on individual ones, I haven't had a problem. Thermostat works great. It's very simple. There's no display to it. I don't really need to know the temperature. As long as I know it's working right, I know what the temperature is because I set it in the program. Eventually I might adapt a screen to it or just put it into my web view, which is where these go from the other board. The new ones I'm going to be installing today will be able to pull up on my phone in a web browser and turn on and off the lights in each location I want. And that's what I separated away. I separated the thermostat and the timer away from that. So they're individually, and now it'll just be one board for my web view. So until I get that, like I said, until I get that figured out, I've got 3 boards there. And once I get my system all together, then I'm gonna make my own board and put it together like this, and I'm gonna use something similar to how I did the power and the fuse and things. And it's pretty neat, and I'll show you part of that right now. Okay, so it's kind of disguised. This is a QC Power Max. Got this. It went bad, and they was throwing it away, so I ended up getting it. So I like to do things like that. I pulled the power supply out and separated it from this board. Made some modifications on this board, which typically would be your camera power feeds. Power for, I think this one will do 18. So what I did, these were all tied together. I think there was just like a 12-volt rail running down that all tied them together, and then they are all fused. So what I did was take a Dremel drill and cut out the traces between each one. I think all the way down to 9. So these are all, let's see, yeah, from here down is all 12 volt. They're all tied together. This is my 12 volt portion of it. And you can see, okay, so it's got 12 volt on the board here, and this, I'm still using the LED light that's on here. And I just soldered my 12 volt in down here. Okay. Alright. Now for up here, like I said, I cut the traces, so I soldered wires to each one. And let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 different spots. And right now this is all these, let's see, this board and this board is being powered from a laptop, which is monitoring the timer. It can monitor the thermostat if I want it to, but like I said, I don't really need to, as long as I know it's working, and I can tell by comfort in here if something's wrong. So I'm using so I've also got some timers and lights on here. So I have some LED lights that come on when the timer comes on, and what the timer is for certain electronics in the house, particularly right here. These will kick off at a certain time of night. That way the wireless, my internet, all that stuff is down. Then these will come back up in the morning. So that's the timer relay for that. And then there's some LEDs that come off of that as well. And timer and LED. And then right here's the thermostat. So when this thermostat kicks on, what this does, this feeds 5 volt to another one of those relay circuits. And down here it feeds power out, and that opens the relay on my climate system transformer. So that way my transformer is not running all the time waiting for the 24 volts from the thermostat. This way my transformer is not running until it's being called for right here from my thermostat, and then it kicks on the relay to the 120 volts, which then allows the transformer to run. And I believe I actually save a lot of energy doing it that way. Otherwise, if you're not even using, you're in the months even that you're not using your air conditioner or heat, your transformer's still running on an older system. And some of the new ones, even newer ones, not the brand new ones, they're a little smarter. So like I said, right now this is only being controlled from my PC because I'm still working on this with the issue I had too with these other two boards. So this one's on the PC, and these two here are running power from my laptop, and my laptop is plugged in. If I lose power, it'll continue to run these two with the LEDs on the battery, but if they lose power, then I lose my electronics anyway, until the battery backup runs out, which I only try to just keep my modem up at that point. Alright, well that's enough for this video. I'm going to make another video on hooking these up and hooking up the relay circuit to show a little more about that, and maybe you'll have an idea of how maybe you can utilize these. I'd be willing to share the circuit and the board design, I guess. Though I do have them posted on eBay. They're kind of cheap, but they're expensive at the same time, and I do know that because the data jack and the relay they're pretty expensive to buy in the US, so unless you're buying thousands of them, which I'm not going to be doing, so they are kind of expensive, but they're a kit. You put them together. I did a video last night on that, got to the end of it, my phone died, and pulled it up, and the video's gone, which has happened twice in the past week, so I got to come up with something else for that. But alright, take it easy. Thanks for watching.